So dear students, let us continue with our basis of vector. And in this slide, we are going to be talking about the triangular or the triangle law of vector, as it is popularly called. Now, about the triangle law of vector, we can write that the law states that when two vectors represent the successive sides, when two vectors represent the successive sides of a triangle, and the third side, and the third side, and the third side is in opposite direction. And the third side that is in opposite direction will always gives the sum of the two vectors or the resultant So the triangular vector you might have also studied in your dynamics as when you have two or more vector that is represented on the triangle, the two sides of the vector are always going to be in such a way that the third side, which is the one joining the two vectors, is called the resultant vector, and is always the addition of the two other vectors. Now, dear student, this is more or less like what I have explained in the first section, the first slide of this video. That is when I talk about the introduction to representation of vector. I explained very well on how we can express vector pictorially and mathematically. Now, doing so now, we are still going to use that same law to understand the triangular vector. So if a triangular vector, if you're asked to state it, it's very simple to write. You just state it with the examiner that when two sides of a triangle represent the two sides of a vector, and the third side is always acting in opposite direction, we always give the sum of the two vectors, which is also called the resultant vector. So I hope you understand this, and let us consider what we're talking about. Now we have first vector as explained. It's a vector A of magnitude. We have a vector, as you can see, my dear students, we have vector A in this direction, and we have another vector we call vector B, already discussed. You still remember now vector B is having magnitude and direction. We have vector B is having magnitude of B and the direction towards the positive x-axis, as I have explained in the previous slide. So this is the direction, which is always towards the x-axis, and this is vector B moving in this direction. Now, according to the triangle law of vector addition, we can combine these two vectors together to have the third vector we call vector C, and which we call the sum of A and B. Now, from what we have actually said or discussed in the last slide, it is more or less like representation of vector pictorially. So now, from what we discussed, we said now we can now have the first vector, which is this, as you can see, and the second vector, which is P, which was acting in magnitude and direction. Diagram not drawn to scale. We are only trying to analyze and make sure we understand all this stuff without any issue. Now, this is the second vector, which is B. As you can see, my student, look at B. B, let's say B is moving. I said diagram not drawn to scale. As you can see, this is B from here to here, and it's having an angle of theta, which I'll show here. The direction is always towards the positive x-axis. As you can see, this is x-axis. It goes without saying, this is x-axis. Now we are combining the two vectors together. This is vector A. No doubt about that. This is vector P in this direction, as you can see my gesture. Then we are now going to join vector A and B together to have the third vector, so that this is going to form a triangle. I believe you guys are getting all my explanations. So going by that, joining A to C, remember, we are going to have the third vector, which makes this thing to form the successive sides of the triangle. You can see it's moving from A to C, not from B to C. So it's always going to move towards the what? The direction is always towards the x-axis. That is why I'll put the direction of this third vector with third vector C. Yes, students, I hope you are following. And the direction I'm going to call alpha. So I hope I understand. Vector B is having direction of theta. That is always towards the what? The positive x-axis. The third vector, which is also called the resultant vector or the sum of the two other vectors. So we can write this technically, pictorially, as C vector is equal to the sum of A vector plus B vector. So I hope students understand this. And this exactly is exactly like pictorial form of what? A representation of vector. But we are talking about this, and we are using the triangle law of vector to get what? Our answer to our resultant vector, which we call the C vector. Now, from your trigonometry, you know that you know very well that if this is theta, angle on a straight line is 180. This is going to give you 180 minus theta. I hope students still remember this very well. And from that, we can apply our cosine rule. So without wasting time, we now say using cosine rule. Using cosine rule, we have directly we can say the resultant vector, which is the sum of the two other vectors, is now equals to, from cosine rule, you have c squared, which is the third one, the square of the two other side, a squared plus b squared minus twice the product of a and b, then cosine of the angle between a and b. You can see the angle between a and b from what? From mathematics is 180 minus theta. So we put in brackets cos 180 minus theta. Now, directly we can now say here, from trigonometry, we might have learnt in our early classes that cos 180 minus theta is at the second quadrant. And because of that, it is going to give us negative cos theta. You can also, for those of you who know about unit circle, that's also very simple. And for those of us who are seeing this for the first time, you don't need to be to be afraid, as negative is always the value of cos of what that is greater than 90, which we call the second point. So keep that at the back of your mind. So doing that here, we change cos 180 minus theta to cos theta, and you can see to minus cos theta. This minus is going to have effect on this minus. And we have our formula, which we use for triangular vector, as c squared is equals to a squared plus b squared. As you know, minus times minus here is going to turn to plus 2ab cos of theta. As I have changed cos 180 to minus theta to minus cos theta. And this formula, you can always keep in mind. And if you like, you can also write it in form of the direct answer by saying c is equals to square root. To get direct solution, you have a squared plus b squared plus 2ab cosine of theta. And this is the direct formula we use to get the magnitude. Keep it in mind, the magnitude of resultant vector. So next time we start work example, you see me using this formula, you don't need to have any issue with that. Then we quickly talked about the direction in this slide. Now about the direction, a quick one, I'm going to manage the remaining part of this slide to explain the direction. Now about the direction, because we said vector has both magnitude and direction. About direction, we use the sign rule. Remember the sign rule in your mathematics class, and if you don't know about sign rule, don't worry, I will tell you what you need to keep in mind. Now, about the sign rule, we are going to consider because we want to get this what the direction of what of the what resultant what vector, which is the third vector here that is forming the triangle, which we call alpha. So that being that, I know the angle of this. As you can see, I know the angle of this. This is facing this. So I can say, and also from what I have calculated now, my dear student, you can see this direction. This is B vector is facing alpha. So I'm going to say from sine rule, directly I can say B, excuse me, let me change my marker ink. We are going to have B over sine of what? Alpha. As you can see, we are taking side of the vector to the angle it is facing. Must be equals to, this is the way we represent that, must be equals to, excuse me, this is, okay, we have must be equals to, from what we have here, just to, this must be equals to, and meets me with what I'm saying here. That's for some minutes, guys. Oh, fine. So we have this must be equals to, what we have here, my dear student, is the other angle here is C, which is the resultant we are looking for, all over the angle C is facing here is 180 minus theta. So I hope students are getting this. From cross multiplication of early classes, I am going to have nothing but I'm making this of the formula sine alpha. I'm going to have sine alpha. Please follow me, my dear student. Is equals to, I have what you can see here. We have this is sine, sorry, not just 180. This is sine 180 minus theta. So I have sine alpha is now equals to B sine 180 minus theta divided by C. So as you can see, which we have talked about here, and sine 180 minus theta at the second quadrant, remember that is the same thing as sine theta. So for those who don't know that, you can keep that in mind, as sine 180 minus theta is the same thing as sine theta. What I mean by that, at the second quadrant, sine is positive. So a quick one here, we are going to have, all what we are going to have here is just writing this one as this form of equation. Directly we can say we have sine alpha is equals to, I hope students are following, B sine theta, as I have changed sine 180 minus theta to sine theta over C. And making that subject formula, we can say alpha is sine inverse, which students like to call arcsine. Sine inverse of B over C sine theta. So you keep this formula in mind, my dear students, as the formula we use to calculate the value of the direction of the resultant vector. It's just taking the ratio of the second vector divided by the third vector, then we take the sign of it, and also remember to take the arc sign of the value. So please keep this in mind, and this is where I will stop this video. And next time, I'm going to make show what we call subtraction and component of vector. See you soon, and do have a wonderful. Bye for now.